Watch the line, bring it down slow. Hold steady on the left, pull hard.
In the early 1930s, building a bridge across the Golden Gate Strait seemed almost impossible. The water below was deep and unpredictable. Powerful tides rushed through the narrow channel every single day. Dense fog could hide the shoreline within minutes, and strong Pacific winds battered everything in their path. Many engineers believed no bridge could survive here, but one man refused to accept that. His vision would challenge the limits of engineering and forever change the skyline of America. Today, the Golden Gate Bridge is one of the most recognizable landmarks in the world. Every year, millions of people drive across it without giving a second thought to how it was built. To most people, it's simply a bridge connecting San Francisco to Marin County. But beneath its towering steel structure lies one of the greatest engineering stories ever told, long before the bridge existed. The only practical way to cross the Golden Gate Strait was by ferry. As San Francisco grew into one of America's busiest cities, those ferries became overcrowded, slow, and increasingly unreliable. People needed a permanent crossing. The problem was, the location seemed impossible, and that was only the first obstacle. The Golden Gate Strait isn't an ordinary stretch of water. It's the narrow entrance where the Pacific Ocean meets San Francisco Bay. Every day, millions of gallons of seawater flow through this passage as the tides rise and fall. The currents can move at speeds powerful enough to challenge even large ships. At the same time, thick fog frequently blankets the entire area, reducing visibility to almost nothing. Strong winds sweep through the strait, while the nearby San Andreas Fault reminds engineers that powerful earthquakes are always a possibility. In the early 20th century, many respected experts believed building a suspension bridge here was simply unrealistic. The technology existed, but no one had ever attempted a bridge under conditions quite like these. The risks were enormous, the costs were staggering. And during the Great Depression, finding enough money to fund such an ambitious project seemed almost impossible. Yet despite every warning, one engineer believed the challenge could be overcome. His name was Joseph B. Strauss, and his determination would set one of the most ambitious engineering projects in American history into motion. But convincing people to build the bridge turned out to be just as difficult as building it itself. Most people believed the Golden Gate Bridge would never be built, but one engineer refused to accept that. His name was Joseph B. Strauss. For years, Strauss traveled across California, presenting his vision to city leaders, engineers, and local communities. Many experts criticized his proposal. Some argued the water was too deep. Others believed the powerful currents and constant winds would make construction impossible. Then came another major obstacle: money. The United States was entering the Great Depression. Finding enough funding for one of the most expensive bridge projects in American history seemed almost impossible. Yet Strauss never gave up. After years of planning, public debate, and engineering studies, construction officially began on January 5, 1933. But breaking ground was only the beginning. The real challenge was figuring out how to build a bridge in one of the harshest environments on the West Coast. And before a single tower could rise above the water, engineers first had to conquer the ocean itself. Before engineers could build the bridge, they first had to build its foundation. That was far more difficult than it sounded. The Golden Gate Strait wasn't calm. Powerful tidal currents rushed through the narrow channel every day, while waves from the Pacific Ocean constantly battered the construction site. For the South Tower, workers had to build a massive temporary platform in the open water. Heavy steel and concrete were carefully lowered into place, creating a stable working area above the relentless tides. The North Tower presented a different challenge. It had to be anchored directly into solid rock near the Marin shoreline. Every measurement had to be exact. Even the smallest error at the foundation could become a much larger problem hundreds of feet above. Engineers worked around the clock, carefully checking every level, every bolt, and every section of reinforced concrete. It was slow, dangerous, and incredibly demanding work. Only after the foundations were strong enough could construction of the bridge's towering steel legs finally begin. But lifting thousands of tons of steel into the sky would become an engineering challenge unlike anything America had seen before. With the foundations finally complete, the next challenge was building the two massive steel towers that would support the entire bridge. Piece by piece, huge sections of steel arrived by barge and were lifted into position using powerful derrick cranes. Each section had to be aligned with incredible precision. Workers balanced on narrow steel beams, hundreds of feet above the water, often surrounded by thick fog and powerful winds. There were no modern safety harnesses like those used today. Instead, the construction team introduced something revolutionary for its time. A giant safety net was suspended beneath the work area. It stretched below the bridge like an enormous safety blanket, saving the lives of 19 workers who became known as the Halfway to Hell Club. Even with this innovation, construction remained extremely dangerous. Every rivet had to be heated until it glowed red, thrown through the air to another worker, and hammered into place before it cooled. Thousands upon thousands of rivets locked the steel together, transforming individual pieces into towers that rose more than 740 feet above the water. By the time both towers stood complete, they had become the tallest bridge towers ever built. But surprisingly, the towers weren't the hardest part. The greatest engineering challenge was still ahead, connecting them with cables strong enough to hold the entire bridge. With both towers finally standing, the bridge still couldn't support a single vehicle. The most important part had yet to be built: the suspension cables. At first glance, they looked like two enormous steel ropes stretched across the bridge. But they weren't manufactured in a factory and lifted into place. Instead, they were built one wire at a time. Engineers first stretched a thin guide wire across the Golden Gate Strait. Then a special spinning wheel traveled back and forth between the two towers, carrying thousands of high-strength steel wires across the open span. This process continued for months. Each new wire was carefully placed beside the last until they formed massive bundles containing more than 27,000 individual steel wires in each main cable. Once every wire was in place, workers compressed the bundles into their final circular shape and wrapped them in protective steel wire to guard against corrosion. The finished cables became the backbone of the entire bridge, strong enough to support the weight of the bridge itself, along with thousands of vehicles crossing it every day. But the cables alone couldn't carry traffic. The final challenge was hanging the roadway beneath them, without throwing the entire structure out of balance. With the massive suspension cables finally in place, engineers could begin building the bridge deck. But there was one problem. The roadway couldn't simply be built from one side to the other. That would place too much weight on a single section and create dangerous stress throughout the structure. Instead, workers built the roadway in carefully planned sections. Each steel segment was lifted into the air by cranes, then suspended from the main cables using vertical hanger cables. As every new section was installed, engineers constantly monitored the bridge's balance, alignment, and weight distribution. Even a small mistake could affect the entire structure. Piece by piece, the gap between the two shores slowly disappeared. After more than 4 years of relentless work, the final section of the roadway was locked into place. For the first time, San Francisco and Marin County were permanently connected by a single bridge. But before anyone could safely cross it, the structure had to prove it could withstand the forces of nature: strong winds, heavy traffic, and even the constant movement of the bridge itself. The greatest test was no longer building the Golden Gate Bridge. It was proving that it could stand the test of time. Completing the bridge didn't mean the work was over. Before it could open to the public, engineers had to prove it was safe. Every part of the structure was carefully inspected. The towers, the cables, the suspenders, and the roadway were all checked to ensure they could carry enormous loads without failure. On May 27, 1937, the bridge welcomed pedestrians before vehicles were allowed to cross. Tens of thousands of people walked across the Golden Gate Bridge, celebrating an achievement many had once believed was impossible. The following day, traffic officially began moving between San Francisco and Marin County. But the real success of the bridge isn't measured by its opening day. It's measured by the decades that followed. Engineers designed the Golden Gate Bridge to move. On hot days, its steel expands. On cold days, it contracts. Strong winds cause the bridge to sway gently, allowing it to absorb energy instead of resisting it. Over the years, the bridge has also been strengthened and upgraded to improve its resistance to earthquakes, helping it meet modern safety standards while preserving its original design. Nearly a century after construction began, the Golden Gate Bridge remains one of the world's greatest engineering achievements. Not because it was easy to build, but because engineers found solutions where others saw only impossible obstacles. Today, millions of people cross the Golden Gate Bridge without thinking about the extraordinary engineering beneath their wheels. But every cable, every tower, and every steel beam tells the story of people who refused to accept that impossible was the final answer. Their determination didn't just connect two shores, it changed the future of bridge engineering forever. But here's something to think about. If engineers could build the Golden Gate Bridge using the technology of the 1930s, what impossible structure do you think humanity will build next? Let us know in the comments below. And if you enjoyed this documentary, subscribe to Nova Theory for more stories exploring the science and engineering behind the world's greatest achievements.